Hello everyone. Today we're going to look at quadratic functions, section 8.5 from the text. Remember last time we looked at linear functions. Linear were things of the form ax plus b, right? Which just means you take some number, any number you want, you multiply it by x and then add another number, and as x changes you get various points along the graph and it turns into a line of various sorts. Now we're going to have, as I say, quadratic functions. They're of the form f of x is equal to ax squared plus bx plus c. So notice that we now have three constants that we need to find out or ask about, determine. But more importantly, the one constant is in front of an x squared. And so the highest power of x now is not x to the first power, but it's x to the second power. And so we're going to learn why these things are very important and why they're useful and why we should spend a little time becoming acquainted with them. So let's take maybe the very simplest one. Let's just take this one right here. F of x is equal to x squared. And remember what we do. If you want to graph it, you can just make yourselves a table where you put x along the left column, and then the y value is the value of the function. So for any value of x that you stick in there, whatever number comes out, that becomes the y coordinate, and then you graph them. So let's see, let's take some easy ones. If you stick in 0, we get out a 0. If you stick in 1, you get out a 1. You stick in a 2, 2 squared is 4. Put in a 3, 3 squared is 9. Throw in some, or go it up to 4 if you want to. 4 gives you 16. Negative 1 gives you 1 again. Negative 2 gives you 4 again. See that? So if you're to graph this, the graph ends up looking something like this. Of course, again, I throw in the easy numbers, but you can put in all sorts of numbers. The domain are all real numbers. You can put in any real number you want and square it. So the domain is all real numbers. And as you do, the numbers that come out graph into something like this. Okay, it's called a parabola. Okay, and so here's the point. I don't have the axes at the same. There's 1, 1. And there's 2 up to 4 if I had it exactly right, and so on. So that's what that looks like. Okay, notice as I say that the domain is all real numbers. The range is all non-negative numbers. You can include 0 and everything positive, but you'll always get something positive or 0 when you throw in any number you want. So that's f of x equals x squared. And as I say, those are very important. If you look at the headlights of a car are parabolic. And the reason they are is because if you take, it's called the foci of the parabola. If you take a light source and put it there and let the light source go backwards, or however it goes back, it's always going to come out going straight ahead, which is typically what you want in a headlight. It can go in the other direction. If you point a big parabolic mirror up at the sky, or any of the ones you see in people's backyards that collect things for TV reception, there all the radio waves and all the sound waves or light waves, whatever, not sound but light waves of various sorts, electromagnetic waves, they all come in basically parallel. Almost parallel, and so they hit the mirror and then they all get pushed up to that antenna, and so that's why it's a parabolically shaped mirror, and so everything gets set right there. And that's also why you can actually generate incredible amount of heat. If you have out in the southwest, you have mirrors that are shaped like this, and they go on very, very long things like so, and then you have right in the middle of it here, you have a spot where you have oil or something like that, and all this heat from the sun, all these light waves from the sun come and hit this mirror and all get sent right along that line, and then as I say, you have oil or something which is being sent along there, and that gets super hot, and then that can be used to actually generate electricity. So you have that. I don't know if you've ever been to some kind of interesting math museums and so on, or science museums. They'll sometimes have, maybe outside, they'll have two parabolic surfaces that are maybe 50 yards apart, and they're like this, and then two people can be standing right there and right there, and they can be talking backwards, and the sound waves go like so, and then go like so, and they collect right there. And so all these people standing in the middle, they don't hear anything because the sound waves are all dispersed, and they don't hear anything. But this person right here, which is 50 yards away, will hear what this person is whispering. So it's really kind of neat. So anyway, parabolas are used all over the place, and we'll see some more applications of them before we're done here today or next time. So anyway, that's the simplest one. What happens if we alter it just a little bit? And let's get some different colors to alter it. What happens if instead of x squared we have, let's call this one g of x. G of x is equal to 2x squared. How's that going to look in contrast? Well, if you put in the values, you can put in the same values of x, and now you'll see that the y values are exactly double of what these are. So instead of being along here, they're going to be twice as high. So it's going to start at 0, but, and I don't know if it's twice as high or not, but it'll look more like that. So it's going to be narrower and going up at a faster rate. So that's 2x squared. Similarly, if you were to use, say, 1/2 x squared, then that one is going to go up at a lesser rate. Agreed? Because now for any value of x you put in, instead of 9, it's going to be 9/2. So it'll look like this. So it's kind of like lines. Remember lines? The smaller the slope, the less steep it was. And similarly here, the smaller number you have out front, the less steep it is. So you've got that. Last thing, remember with lines, what happens if instead of a positive slope, you have a negative slope? That changes the line more dramatically. Instead of going up like this, it goes down like this. What happens here? Oh, I have two g's. Oh, well, that's okay. Let's say if I let h of x be equal to negative x squared. Okay, can you picture what's going to go on there? For every value of x you stick in, now it's not going to be these values, it's going to be the negative of these values are what come out. So instead of being this graph right here, it's going to be this graph. Okay, the mirror image of this one, okay? The mirror image. And so it's going to go down rather than up. So you can easily start seeing a pattern here. If you have positive numbers in front of the x squared, it's going to open up. If you have negative numbers in front of the x squared, it's going to open down. Okay? So that's that. Okay, let's see what else we can do with this simple one. Let's get rid of these. And let's see if I can get rid of these, how easily I can. Too bad. Okay. What happens if instead of f, I have g of x is equal to x squared, say, plus 2? What's that going to look like? Well, again, just think about what happens. All the x's that go in, now the values that come out are not going to be these values. Instead, it's going to be these values with 2 added on. So instead of 1, it's going to be 3. And instead of 4, it's going to be 4 plus 2 is 6. Instead of 9, it's going to be 11, 18. It's going to be 3 again, and 6 again. So it's always going to be 2 units higher. So it's going to be the same shape. It's just going to be translated. We use the word translated. Translated 2 units up. See that? Does that make sense? Let's try another one. Let's try h of x is equal to x squared, say, minus 1. What would that one look like? Well, now every value that comes out, instead of 0 coming out, it's going to be -1. And when you put in 1, instead of 1 coming out, it's going to be 1 minus 1 is going to be 0. And instead of 8 coming out, it's going to be 9, and so on. So though that's going to be the same shape, but translated down 1 unit. See that? So you can do all sorts of things. Let's combine a couple of them together here. Use all my colors that I have available. How about this one? Let's let k of x be equal to, how about this? Minus x squared plus 4. What would that look like? Negative x squared plus 4. So again, you can just plot points, but notice that when x is 0, you're going to start at 4. See that? You're going to get negative 0 plus 4 is 4. And then, as x grows, this is going to become a bigger negative number. So it's a negative, so instead of growing up, it's going to grow down. So it's going to look something like that. Okay? So that's the idea. Okay, very good. So, what have we learned so far? We know what kind of the standard parabola looks like. We know what happens when we multiply it by constants. We know how to make it turn it upside down, make it go down rather than up. And we also know how to translate it along the y-axis, right? We can. By the way, this is called the vertex. The vertex is kind of the bottom or the top point of the parabola. Okay, that's the mountaintop or the valley or the bottom of the valley. It's called the vertex. Okay, kind of like the vertex of a triangle. Okay, it's where the two sides come together. So anyway, we know how to translate it so that it goes up or down. Question is, how can we make the vertex go off to the side? What if we wanted the vertex to look like this? How could we do it? Well, let's think about it. Let's take a particular example. Let's actually make one here a little nicer. Say I wanted the vertex to be not at 0, but at 3. Okay? So there's 3 right there. How would I have to change? How would I have to change the equation of the formula for the function if I wanted the vertex to be here rather than at 0? Let's think about it. The key thing here, the vertex occurs when you're taking 0 and squaring it. It's 0 squared, 0 squared, 0, 0, which gives us the vertex. So I want something here which is 0 when x is not 0, but is 0 when x is 3. What can I put in here so that this thing will be 0, not at 0, but when x is 3? How about this? X minus 3. Call that g of x again. G of x equal x minus 3 is going to behave exactly the same way there as this one does at 0, because g doesn't know the difference. All it knows is when it sees a 0, it does this. When it sees a 1, it does this. 1 squared, when it sees a 2, 2 squared is 4, it's going to go up. When it sees a negative 1, what does it do? It goes up again, right? What do you have to put in here to get a negative 1? 2 minus 3, there's your 2 right there. 2 minus 3 is negative 1, and so on. So it does the exact same thing at 3 that this one does at 0. See that? So let me give you another one to see if you can figure it out on your own. Let's let h of x, let me give it to you. H of x is equal to x plus 2 quantity squared. What's that going to look like? Well, I look at that and I say, well, what's the thing, what does x have to be in order to get a 0 in here? Okay, well, x plus 2, in order for that to be 0, x is going to have to equal negative 2. So, in other words, this thing is going to look exactly the same as this one, except it's going to be shifted over to the left 2 units. Okay? So you get that. Okay? And so now, let's see if you can put all this stuff together. What would the graph of this one look like? Let's let f of x be equal to 1/2 times x minus 5. Oh, let's make it even tougher. Negative 1/2 times x minus 5 squared. Okay, can you put all the ideas together? First of all, where's the vertex going to be? It's going to be at 5. 1, 2, 3, 4, 5. 5, 0. And notice that it's going to be kind of widened out because you've got a 1/2 there, so it's going to make it kind of wide, a little wider. And it's going to be opening down, agreed? So it's going to look roughly like that. It's going to be kind of wide, going to open down, and the vertex is going to be at 5, 0. What if I added 3 to this? How would that change things? Well, now instead of these values, all of these values are going to be 3 values higher. So the vertex is not going to be there, but it's going to be here instead. It's going to look like that. See that? So that's the idea. So you'll have lots more of these to do in class, but that's the idea. Let's just do one more just to get a little practice. This is really important stuff. How about, I tell you what, let me give you a picture and see if you can figure out from the picture what the won't worry about it too much, but look, something like that. Okay, let's figure out what the equation is. So first of all, here's what I have in mind. It's going to be an x minus 3 quantity squared, because the vertex, the x coordinate of the vertex is 3. Notice that the function is pretty steep, so it's hard to know exactly how steep it is. I don't care. Let's just put a 2 in front. That would make it steeper than a regular parabola. And finally, notice that the y-coordinate of the vertex is -4, which means that when this thing here is 0, you want the y value to be -4, which means you want to put a -4 there. So notice when x is equal to 3, 3 minus 3 is 0, 0 squared is 0, 0 minus 4 is -4. So there you go right there. Okay, and if you made that a negative instead, it would look like what? It would look like that then, agreed? Rather than this one. Okay, very good. So anyway, the only thing left to do, I guess we've got a little bit more to do, but we should be a little more exact about finding out exactly what this value is, and we can find that by finding what these intercepts are. Okay, so let's look at another one here. And let's ask this question. Let's do this. Example. Sketch the function f of x is equal to quantity x minus 3 squared minus 4, and find vertex and intercepts. By the intercepts, I mean the places where it crosses the x-axis and the y-axis. Okay, so let's do it. First of all, here's what the general look is going to look like. It's going to look something like this. The vertex is going to be at 3, -4. Agreed? It's going to be down there. So there's the vertex. Agreed? And let me just make sure that I'm still being recorded here. Okay, I am. Very good. Okay, and now let's find the intercepts. Well, finding the y-intercept is easy enough. All I have to do is stick in x for 0, 0 for x. So f of 0, if I stick in a 0 here, I'm going to get what? 0 minus 3 is -3. -3 squared is 9. 9 minus 4 is 5. So it's going to hit that point right there. There's your y-intercept. Okay? 0, 5. Okay, now we want to find the x-intercepts. So I want to find out, when will this thing be 0? So one way to find out when it's going to be 0 is to say, well, x minus 3 squared minus 4 is equal to 0. So I can go x minus 3 squared is equal to 4. Now I can take the square root of both sides. If I take the square root of this, I get x minus 3. If I take the square root of 4, I get either plus 2 or minus 2. Agreed? Actually, I mean, this one you get plus or minus as well, but as long as you make one of them plus or minus, you've got all possibilities there. Okay, so you got two equations there to worry about. One is going to be x minus 3 is equal to 2, and that gives me what? If I solve that for x, I'm going to get x is equal to 5. Agreed? The other one is if x minus 3 is equal to -2, if you add 3 to both sides there, you get what? If you add 3 to both sides, you're going to get x equals 1. So here are your x-intercepts at 1 and at 5 right there. So notice that the vertex, that the x-coordinate for the vertex is exactly halfway between those. Makes sense, doesn't it? Because there's a certain symmetry there. So it's going to go up like this. I can do it pretty well. It's hard to do it right. There we go. Okay, I'm also going to go up that way. Okay, so there's your, and it should be rounded at the bottom here. Hard to do it right. This is a nice place to use Decimus, by the way. Just put this into Decimus and it'll give you a really beautiful graph. Okay, much better than me. Much better than I. Okay, so so there it is. Okay, there it is right there. So let's use this one just to do two more things. We already know that the x-intercepts are 5, 0, and 1, 0. Okay, we already know that. Let's see once how we could have gotten it a couple other ways besides the way I just did it. Okay, I want to show you two other ways to do it. Here's the equation right here. We want to set this equal to 0. Okay, x minus 3 quantity squared minus 4, if you set that equal to 0. Remember what I just did? I moved the 4 over and then took the square root of both sides. Here's another way. Remember how this thing factored? x squared, or I'm sorry, a squared minus b squared. Remember what that was equal to? That was equal to a plus b times a minus b. Okay, remember that from a couple sections ago? So this thing here factors into x plus 3 plus 2. I mean, here's something squared. 4 is the same as 2 squared. So there I've got one thing squared minus another. So this formula says it's the first thing plus the second thing times the first thing minus the second thing. X plus 3, I'm sorry, there should have been an x minus 3 there. X minus 3 plus 2, x minus 3 minus 2. So the first thing A squared minus b squared, the first thing plus the second thing, the first thing minus the second thing. And so this becomes what? X minus 1 times x minus 5 is equal to 0. Remember, 0 is our friend. If the product of two things is 0, that means that either this thing's got to be 0 or this thing has to be 0. And either way, you get the same that we did before. X is equal to 1 or x is equal to 5. Okay? So finally, I'm going to show you yet one more way. Okay? It's just important to see that there's lots of ways to do these problems once you have some of your math tools. So let's look at our function again. If we take f of x is equal to x minus 3 squared minus 4, and if you were to multiply that out, remember how to use FOIL? What would you get? How do you use FOIL? You go first times first is going to be x squared. Inner gives you negative 3x. Outer gives you negative 3x. That all gives you negative 6x altogether. And then finally, negative 3 times negative 3 gives you 9. And then minus 4 gives you that. And now you have x squared minus 6x plus 5. Okay? So, there is another form of the parabola. Okay? It's exactly equal to this. All I did was just algebraically do things. Notice that this is in the form that I originally gave you. ax squared plus bx plus c. Here we have 1x squared minus 6x plus 5. So that's why I wanted to do this, because this is where we're heading next, is we're going to say, hey, what happens if you have something that looks like this? Can you get it back in this form so that you can graph it? And notice, at least right now, we're going to continue this in the next lesson, but at least right now, if I asked you to factor this, could you do it? Remember how you do it? You look for two things that multiply to 5 and that add to negative 6. Multiply to 5 and add to negative 6. Well, you know they're going to have to both be negative, and I guess it's not too hard to figure that one out. It's going to look just like that. And so there's the factoring. And so again, if you were to set that equal to 0, you get the same thing as before. You get x equal 1 or x equal 5. So this is where we're going to start the next lesson. We're going to break chapter 8 up into 2 different lessons to cover all these sections, and we're going to go on from here. So this is good for the first one. Lots of good stuff. Very good.